All right, in this video, we're going to talk about the Kruskal spanning tree. So let's get started. Before we start talking about the Kruskal spanning tree, we do need to talk about what a spanning tree is. So the best way to explain it is just to kind of show you. So if you look at this graph right here, here is the major takeaway that I want you to kind of think about. Now, remember in this unit, I've said several times that a lot of the graphs that are given usually have a story behind it, but I'm just giving you a graph at this point. So here's the big takeaway, and that is notice all the vertices. See how they're connected one way, shape, or form. All right, now it's not a Hamiltonian circuit, it's not a Hamiltonian path, they're just connected. All right, and they're connected by what we call a tree. All right, so now the thing to remember, again, a lot of the takeaways here, and that is when you are connecting all of the vertices, you are creating a tree, which means it is a connected graph with no cycles. All right, and we'll talk more about that as we dive into a problem. But here's the main takeaway again. Once you walk away from a question, once you or finish a question, all of the vertices need to be connected. All right, so Crescal's minimum spanning tree. All right, so we are going to go ahead and dive into that. Now, it says find the spanning tree based upon the weights of the edges. Now, remember, the weights are the numbers that are on each of the edges here. Okay, so to get started with Crescal is actually pretty simple if you just remember one thing, and that is always start with the smallest edge. So I'm going to write off to the side here. Always begin with the smallest edge. All right. So if you look at the graph here, what is your smallest edge? Meaning, what is the smallest number on an edge? Well, if you notice, it's this one here. All right. So in reality, when you're dealing with this algorithm, you don't have a starting vertex, but you have a starting edge. So I'm going to highlight and connect B and D. All right. Now, once you start with the smallest edge, you then work to the next smallest. Now, if you notice, there's a 2 here and there's a 2 here. All right. So which one do you choose, you might ask? Well, this is where each situation is going to kind of be different. But in this situation, I know I probably just confused you there, you're going to actually use both of them. So you're going to highlight one and then you're going to highlight the other. Now you might think to yourself, well, wait a minute, this edge is not connected to these two edges, but they will be in your final product. So after a 2, what's next? Well, here's a 3 here. So we're going to connect. Okay? Now, after a 3, the smallest one is a 4. So we have one here, we have one here, we have one here. Again, you have 4 or you have 3 of them, but only one of them is going to be highlighted. And so here's where we're going with this. So again, pay attention since this is our first one. If I was to highlight this 4 right here, all right, going back to the instructions, notice here, no graphs will have cycles. All right, so connected graphs with no cycles. So if you were to enclose this right here or highlight this, notice that we have now made a cycle. So the cycle would be here, here, here. All right, we can't do that. We cannot have all of our graph, every part of our graph has to be open. Okay, so that 4 would get skipped. So in reality, what you're doing is you're actually skipping it. So this 4 would not get highlighted. All right, let's see what happens when I do that. Okay, good. All right, now let's say we are to highlight this. Well, again, what have we just created? A cycle. All right, can't do that. All right, we cannot have our cycle. We cannot have a cycle. So that means that 4 will get skipped. But if you notice this 4 here, when I connect B to C, notice that now all of my vertices have been connected and everything is open. So this here would be your final answer. All right. So how do you connect all of the vertices? And by using a tree. There you go. All right, let's do another one. All right, so Kruskal's method to find the minimum spanning tree. All right, so again, starting with the smallest edge. Look at where the smallest edge is. Well, we have two of them. Here's one. I'm going to highlight. Here's another. Again, you might be thinking, wait a minute, they're not connected. They will be. Just give it time. Now, after a 1 is a 2. Well, there's two of them. Well, we can highlight this, and we can highlight this. Now, you might be asking, wait a minute, why could we highlight both of those when we could not highlight all the 4s? Well, the reason why is because none of it ended up being a cycle. So remember, the only time that you ever skip something is when you run into a cycle. So after a 2, then it's a 3. Uh-oh. You see what just happened there? And if you didn't, I'll highlight it. When I did that 3, I enclosed a part of that graph. Can't do it. We got to keep it open. So that 3 gets skipped. So after a 3 is a 4. Well, there's a couple of 4s. Let's see if we highlight this one. I forgot to use the wrong color. But if I use this one, uh-oh, what did we just create? A cycle. Can't do it. So guess what? That 4 does not get highlighted. But this 4 can. There we go. All right. After a 4 is now a 5. So if I highlight this 5, uh-oh, I have just created a cycle. Can't do that. So that 5 will be skipped. After that will be a 6. Highlight 6. There we go. Everything has been connected. And if you notice, I have no enclosed parts of my tree. So that is the correct answer. All right, let's use this one. Now, here is an actual story. All right, so what we have here is a story where it looks like we're in Germany here, and all the cities need to be connected by a telephone wire or connection. Yeah, it looks like a new phone line is being laid. All right, so here we go. So using Kruskal's method, if you remember, we got to start with the smallest one. All right, so looking, the smallest one, I believe, is this 80 right here. So these two cities have now been connected. All right, after 80, let's see, next one would be, looks to be 84, connecting those. All right, after 84, let's see, it looks like 85 is going to be our next one. So we're slowly connecting the towns here. After 85, then we go to, I believe it's going to be 103, connecting this right there. After 103, we're just continuing here. After 103, I think it's going to be 167. So now all that's connected. After 167 is 173, I believe. All right. After 173 is 183, like so. And after that is 186, like that. And then, let's see, after 186, it's 217. Boom, there we go. Everything's been connected. So how much telephone line is going to have to be used, which is the next question. How many miles of telephone cable will be needed to connect all the cities? Well, very simply, what I'll do is I'll just add all of the weights of the edges that I used in my tree, which when I add all those up, I'm going to get a grand total of 1,278. All right? All right. This will probably be our last one here. All right, so find the minimal spanning tree by using the Crescal's method. All right, so again, we're going to go to the one on the left here. All right, so that's where we're going to go. I want to use purple. All right, so we're starting with a 1. So 1, 1. All right, after a 1, then we have a 2. We got a couple of 2s, actually. Actually, we got, I think, 3 2s. 2, 2, 2. Now, after 2 comes a 3. If I highlight that, notice I enclose that part, can't do that. So, but I can use this 3, and I can use this 3. All right. After that, we got 4. All right, so we got a couple 4s here. That 4, everything's still good, but that 4, I've now enclosed. Can't use that 4. That will be skipped. All right, after a 4, we have a 5. Let's see, there's a 5 right here. And then we have, let's see, a 6. All right, so now, in this example, 6 is we have 2 6s. If I highlight that 6, I cannot highlight that 6 because what happens is I've just enclosed it. So what happens is now we run into a situation where you have to choose. So I can either highlight this one or I can highlight this one. Either one will be correct. I just can't do both. All right, so I'm just going to go ahead and choose this one, and I have one more 6 down here. There we go. After 6, there's a 7. There's a 7, and everything has been highlighted. So there we go. There's my tree. All right, lastly, we'll just go ahead and do this one here since we have time. This we're going to go a little faster here just because we've already done this several times. So 3 after 3 is an 8. After an 8, let's see, I think it's, can't do 11. Nope, that's a no-go. But we could do 15. All right, after 15 is 17. I got branches everywhere, but we're going to connect them, don't you worry. After 17, looks like 29 is my next one. I cannot do 31 because it encloses it. So after 31, I believe it'll be 40. Let's see, there's a 40 here. Oh, that encloses, can't do that. But I can do that. And there we go. Got yourselves a spanning tree. Everything's connected. All right. Hopefully that made sense. Thank you for watching. Have a good day.